I'm just kind of going to do a guided demo of some of this stuff pretty quick. Obviously, this is not exactly what the presentation is about, but I wanted to kind of give you a better understanding and visual of how these tools look like.
Before Dustin starts with the demo, does anyone have any questions they would like to ask? Feel free to pop them in the chat box and we can go through those before he gets started.
Okay. I just have to get logged in here. I actually got logged out of another. I promise you won't be able to see any of my passwords. So. All right, so what we're gonna do is basically create an S3 bucket, load a little bit of data into it, use the glue crawler to show you that it can identify the different types of data and create tables out of those, and then query some of that data just to show that really Athena can truly query these flat files, and these ones in particular are JSON files, and then we can actually join tables or join those files against each other. So if we go into here, let's create ourselves a little bucket. Let's east. Okay. And what I'm going to do before I upload this data, I'm actually going to create, so the console likes to call it folder. In reality, that's not how S3 works. It's really just a key prefix. The concept of a folder is really just for us as humans to help us wrap our heads around it. But we're just going to create a couple folders here to house some of this data. And the reason that I'm doing this, as opposed to just uploading the files directly in their flat in this this same key prefix of the bucket, is what the crawler is going to do is it's going to use the individual key prefixes so that I can have multiple files under any individual key prefix, but they still constitute as the same table. This also comes into play with Athena, because Athena actually needs this in order to be able to query. Interestingly enough, when you query using Athena, you can't point it at a single file. It'll actually return 0 results. You have to point it at a key prefix in order for it to work, because it expects that there is multiple files that comprise a single table. So we'll just go through here and we'll upload our individual files. I've done all this as just a set of commands, but I did not have time to write that out ahead of time. Okay. All right. So then we've got, this is the Glue console. And you can see that we've got a bunch of different things in here. We've got different databases, which we haven't defined one yet. But we've got databases and tables, basically our catalog. We've got a number of crawlers that we can define to target different paths on S3 or other data sources. We can create different jobs. We've got dev endpoints, which is going to be very important when it comes to hooking up maybe a notebook to be able to do some of our work creating a model. But what we're going to do here, so we'll just define just a database so that we can house these in here. Oops, wrong one. I'm going to create a crawler. A lot of these and we will give it the path to my bucket here. These are all just kind of different settings that you can provide. I'm more or less skipping over them because they're not important for the purposes of the demo. But so I created a crawler and I pointed it to the location on S3, basically this bucket that has all these different prefixes. And now oops, that's not what I want to do. Now I can come in here and I can just say, okay, run my crawler. So again, this is serverless. I don't necessarily need to spin anything up myself. Under the hood, sure, I'm sure that there's EC2 instances under the hood that are taking on this task, but I don't need to manage them. I don't need to manage the security around them or provisioning or deprovisioning them. So this is basically going to start up. It's going to look at that bucket and it's going to look at all the files in that bucket. And based on what it sees, it's going to populate the database that I just created with tables that point to the results of those, or that point to the locations of those files. And depending on, obviously this is dependent on how many files that you have. Maybe you've got a bucket and it's got millions and millions of files, then obviously it's going to take a little bit longer. But you can also point it to specific key prefixes within that bucket in order to narrow down the scope at which you're crawling. There's probably not a way to do like an ad hoc poll on here, is there, Courtney? I don't think so.
Not an ad hoc, but you could ask a question and we can all chat in the chat box.
Or press,
Yeah,
or yes, no. There's a yes and no option if it's binary.
Well, I was just curious, how many people on the call, have played around at least even with AWS at all.
It's binary.
That is true.
Couple yeses.
Okay, so my crawler stopped. And now I can see that in my database that I created, I have these, different tables. And you can see where the location is that, it identified that each individual key prefix was its own table. So I've got /areas, /countries, events. So this is great because, now that I have a catalog in my table, I've got a bunch of AWS services that are all hooked into this catalog. So, I can go over, say, and I can look at Athena. Some of these. And it has picked up that I have a database called Legislative, and I've got a bunch of tables in here. One thing that I will need to do is update this. real quick here, I will create another bucket. Just give it a random name. So basically, when I run a query on Athena, like I said, the results of that query don't necessarily come directly back to the console. They're actually put into another S3 bucket or wherever you specify. Thing seems to be locked up. My computer is working real hard right now. Grab the name of this, and I will point it, basically point where I want my results to be there. Simple enough, but so, okay, I've got Athena and I've got these tables. You know, what I'm really curious about is, you know, what am I actually looking at? So I can preview it just like I would normally do with a lot of other database IDEs. You know, that's going to basically generate the statement, select star from that table and just a limit of 10. You can see here I've got, you know, some various data, obviously alluding to the fact that my database is called legislative. Maybe if I look at persons, okay, so I've got some various information about the names of various people. I can look at, you know, you can see obviously these are nested JSON structures and there's syntax available so that I can query that nested JSON directly. But I've got all sorts of data information in these files that I can query against directly. But it's not necessarily like, while it's useful to be able to just look at these individual files and see what I have going on, you know, I might want to do a little bit of analysis. So I know I wrote this last night, just a simple query, but, you know, let me look at, because I noticed one person's name on here, Bill Huizenga. All right, well, let me find out a little bit more about him. What organization part is he part of? What area is he in? So I can query across these different JSON files. Okay. Oh, I didn't rename my database. Okay, so Republican constituency, part of Michigan's 2nd congressional district. So, you know, this is great because I don't necessarily have to load this into a data warehouse, into a relational database in order to be able to get a little bit more information about this stuff that, you know, it might just be leading into more further analytics. This might help me define what the more hardcore analytics processes that I want to run in a data warehouse might be. And that's a common use case. I might have all this data from these disparate data sources, and then it's good that I have them because it's cheap storage and I can figure out what I have. But then if I want to create any real analytics, that's when I want to start using something like EMR. That's when I want to start using something like Redshift. I can load it into those downstream sources and then perform the real work there. And it's all about using the right tool for the job. We have a million different tools in AWS, not a million, but dang close. You know, use them appropriately. Let's not just try to fit everything into one box. Just as another, you know, to further illustrate the point, you know, say I've got a glue job, you know, I could create a new job, give it a role. But this is where, you know, I can say, okay, well, what do I want to act on? All right, well, I want to act on persons. Maybe I want to transform this data set a little bit. I want to change the schema. So, okay, great. This is a one-to-one mapping, but maybe I want to remove some of these. Maybe I just want to clear out all of these. So I could add a column and say, maybe I only want, you know, the given name And then I can come in here and I can say, okay, well, map that to given name. And I can do all these basic transforms because they're part of most ETL workloads. This isn't any crazy heavy lifting, but it does offload some of that boilerplate from me. Because now I can come in here and I can say, save the job and edit the script, and it will generate the entire script for me so that I can take over from here and do more meaningful work. So, that's really all I have for you guys. I really, I just wanted to illustrate that the, AWS and the concept of a data lake is the prime use case for machine learning and using artificial intelligence, creating these models. But there's a few steps that we need to take in order to get to the point where we can actually utilize that data, where it's actually sanitized and it's in the correct form. And these are the tools that we want to use. We want to use Glue. We want to use Athena. We want to use different Glue jobs and ETL processes. This is what's going to enable us to go on and do better work.